Yet another draft physics video production. Overview kind of video again, just kind of pointing out the distinction between the two theories. The conventional stuff and my stuff, whatever. The alternative view, the simpler, more logical, evidence based diagram of reality. And it comes down to something I call 2 plus 2 plus 2 physics, in the sense that it's really quite simple. There's stuff called force moving the speed of light. It has two identities, a plus and a minus, a north and a south. And there's stuff called matter, and that's fundamentally just electrons and protons, the charged elements. So they come in plus and minus, north, south. The electron and the proton are the magnetic monopoles. And there's only two kinds of interaction, fundamentally reflection and deflection. And that's all that happens in the universe, and everything can be understood by just understanding that momentum has to arrive through a mechanism where something has to hit something, essentially, interact with it. And there's no ether thing. It's superfluous to any function. You can do it with sticks and stones, if you want to use that kind of analogy. Yeah, I chose to. So anyway, regular physics says physics isn't simple like that. There's this gravity stuff, and the gravity is controlled by something called bent space, and it's really bent space time. So I guess I'll have to deal with that, which is some sort of this in space, some sort of geodesic, they call it. And the geodesic, that is these bending lines, these lines all bend into the center, and they all bend in by this r squared rule, which is not visible. And so it's really quite simple, but quite ludicrous in the sense that the prediction is that the photons are twice as affected by gravity, and that somehow there's a thing called lensing happening, gravitational lensing, where photons are bent, but they're bent by a lens that's literally shaped like this. It's that bad. Okay, so the lens, you can't even really draw it, because you want to just cut those two proportions in half, and the 0 point comes in the middle. So the bent glass is this way. Now, conventional lens is like this, of course. And so, fundamentally, this isn't going to do what this does, which is magnify to a focus. This is going to do the opposite. It's going to make a horrible mess. So it doesn't make any sense theoretically. It's the wrong lens. The gravity gets stronger the closer you are, where a lens bends more the further away you are from the center. Completely upside down, right? Yes, you have to agree. Okay, anyway, so we'll go through some of that stuff. And the other theory they have, because they don't have one, they have two theories of function, where movement comes from. So they say some movement is caused because matter creates a dent in some sort of space, geodesic thingy, ether, whatever, just by existing, no energy required, and stuff falls into the dent in the space. It's that bad. They might as well talk about the great bear that eats the moon or something. It's cheese, moon cheese, as an explanation. But anyway, the other one is QM, quantum mechanics, which relies on something called a virtual photon to do this moving stuff. It behaves like a photon, but it's not. It's some sort of wave. So they have this thing called a wave function, okay, which is this capacity of everything that looks like a thing to somehow not be a thing, where it doesn't know where it is, and it's creating a bunch of waves as if it was a whole bunch of things. So as if it was a bunch of things going in a bunch of places, somehow the single thing behaves like that, and somehow retracts all that crap. Like it didn't really, even though it did go to these places, it didn't really go to these places, and it really did just land in one place after it did some calculations to figure out the optimum path. probabilistically, what its obligations were probabilistically, because it knows what all the other photons have done, and so it knows that, oh, I can't go over there because too many people have sat in that chair, so I'll go sit in the chair that was only sat in 4 times. Somehow it knows how to do probability, when we know that from every example of a probabilistic outcome that we know of, the dice don't know what the previous dice did, they don't know what the future dice are going to do, and somehow it comes out right. And it comes out right because the dice don't know nothing. Okay, the surfaces the dice bounce off decide the probability. They decide the outcome. But regular physics doesn't think surfaces matter. It doesn't matter where you throw the dice, what they hit. Irrelevant. The dice somehow know where they're supposed to do, and know what probability is, and know they're supposed to come out with a certain outcome. So it really is that bad. I'm saying, why should I have to make this video and go any further? I mean, the more I explain it to you, the more ludicrous it's going to get. So let's start with this idea of time, okay, being some sort of dimension, like it's the 4th dimension. All right, well, let's understand the dimensions are this, in and out. So you got in, out, up, down, left, right. So you got 6 sub-dimensions to the 3 fundamental dimensions. How does time fit in there? How do you put a 4th dimension in there? Is there any room for a 4th dimension? You've basically now made a sphere with the 3 dimensions. What are you going to do to it? How are you going to bend it to make time fit? There's no place for it. All right, so let's understand this. Easy explanations for what time dilation is. This mysterious time dilation that's, just can't be explained, can't be understood, can't be, the fact that a clock might not work as well. And that's all that's really happening. So here you have something sitting in space, and it has an action. The action is some little bits going around this. Let's just say that's the action. It could be any kind of action. But let's just make it nice and simple, nice and circular, nice and round, nice and simple. So this action, what's going to happen to this action if I give this thing motion? Right? You can sort of understand, well, this thing will have to go this way and then make it circle. Well, that's going to be, means it started here, that means it's going to travel a bigger circle each time it goes around, because it's collecting distance in this direction. So it's going more distance in this direction. So the circle is getting fatter, okay, in one direction than it was in the other direction, and that means it's getting bigger. The circumference, the length of this orbit is now longer. Well, it doesn't have any more momentum, effectively. It doesn't have any speed change. It doesn't do anything. It can't compensate for the longer path. So the longer path takes more time. Okay, it just does take it more time. So this is just a multitasking argument. This is just an argument like if you're a skilled bricklayer and then somebody asks you to do an hour's worth of snow shoveling. You're not going to lay as many bricks. Doesn't sound quite right. You're not going to, right? You're not going to do as much brick work because you have to take an hour out of your time to go shovel snow. And that's all that happens with time dilation, is it just breaks the metabolism of atomic function. Atoms have a metabolism. Stuff is going on. They're jiggling. They're in positions. They're doing stuff. And if you ask them to do something else, they can't do the stuff they were doing at the same rate. They can't vibrate this way the same amount, the same speed, if you're forcing them to move this way or even that way. No matter what way you move them, they have to travel a longer path to go back and forth. So you can understand, if I force this to move, then the path gets longer for this object. Even though the direction's this way and it's not even in the same direction it's moving, the vibration takes longer because it's moving it. It's taking the vibration and forcing it to change its position. When you change its position, that's distance. Distance takes time. So the simple explanation is clocks break. People don't. Well, people do in the sense that their physical structure breaks. When you move them enough, you start changing these frequency so much that the whole thing breaks into pieces. It doesn't time dilate. It doesn't go to the future. It dies. It falls apart. And you can see that happen with acceleration. If I accelerate you enough, okay, I smash your brain cells into the wall of your skull and you die. You don't go to the future. You don't go anywhere. You die. And so I mean, all this is just it's just call it baby talk, but I mean it's a little kid imagination Star Trekky kind of bullshit. It's fun, but it has nothing to do with reality, in the sense that there's no time, location, there's no frame of anything. There's no place where something different happens. Time is the same everywhere in the universe. The clock, the real time is ticking 1 second, 1 second. The amount of time it takes to cover a distance remains the same for a photon of light. And the photon of light kind of proves the whole case, because the light clock kind of gives you the proof, because you can't break a photon. Photons don't care about what's moving around them. They'll do exactly the same thing. And so they'll show you that your rocket ship is moving, because the photon will start here and it'll land on some other surface of your ship, because your ship moved while the light was transmitting. It transmitted exactly the same speed it always travels. It's traveled in exactly a straight line, but the side of your ship moved. That's all that happens. All right. A little quickie on the lensing. Which is another one of the predictions of general relativity. It's not a prediction, in the first place, and it is just kind of made up because Einstein had to make elevators in space or rocket ships the same as the gravity on Earth. And here the argument's kind of simple, that you can understand that if I'm going to move something and it's made of little pieces, I'm more likely, okay, so here's two things exactly the same, made up of little pieces. Okay, and one thing I'm going to move by a little arrow, okay, and it's going to push into it. And the other thing is going to get hit by a whole bunch of little bits. Okay, so the force is going to be spread out, and it's going to hit all of these almost at the same time, except for their relative distances away. But it's going to kind of have a personal relationship with like 90% of them. It's going to hit directly, and the rest of them will get pushed by this one moving into that one and that one moving away and all that kind of stuff. But this one, everything has to come from one point. That means one little bit has to hit another bit, and then that bit has to hit another bit, and that bit has to hit another bit. So this acceleration is going to be much slower. Okay, it's going to be slow. Okay, get rid of the M. It's going to be very slow in transmitting the energy, and this is going to be very fast in transmitting the effect. This is going to be very effective. That is, in 1 second, it's going to have this thing moving much faster than this thing is going to have this thing moving. And so when Einstein says it's all the same, it's clearly not the same. When the floor of the elevator is pushing you, it's different than when you're getting pushed by gravity. Gravity hits a lot of your stuff now. The elevator has to push all the energy through your bones, through everything, and it has to vibrate through you, and it takes a while, and that's why you start to compress. It's because your body doesn't do it as fast as it needs to. Okay, the elevator keeps accelerating. Your body hasn't caught up yet, and so parts are left behind, so to speak. There's all kinds of stresses, all kinds of points happening, where the tissues are kind of ripping off your bones in places, and little things are getting stressed because there's too much energy in confined locations in trying to disperse it throughout the whole thing, where with gravity the energy is dispersed quite evenly. So a simple flaw in the logic of Einstein, they're not the same thing. Because you move doesn't mean you got moved by the same process. The processes are different. So there's no reason to think photons in rocket ships that go down are going to be just like photons in gravity and go down. There's no down, because the objects are the things getting pushed in gravity, where it's object against object. In gravity, it's force against object. In acceleration in a rocket ship, it's object an object hits another object, and the force has to be transferred. And it isn't some sort of perfect kinetics. It's a very imperfect kinetics that accomplishes the task. So a huge flaw to predict lensing. Okay. No reason to. But that was the motivation of Einstein, is to try to make everything equal when they're not equal. And the consequence was some guess that photons are somehow bent by a force, like no other thing in the universe is bent by anything. You can't bend them with magnetism or electricity, the things they're supposed to be made of. Those don't work. Why would gravity work? There's no logic to it at all. And then I made the simple argument over and over that, you do a little bit of research and you do a little thinking on the subject, and you know that bent space does this, and conventional lenses do this. So this is where the high bending is, okay, is where the line is crooked. So it's exactly the opposite. Gravity bends a lot towards the center, and and lenses don't. And then we know that lenses aren't sloped. This slope on a lens isn't anywhere close to r squared. Where we know this slope is. This is an r squared slope. That means it's rather dramatic. Lots more gravity, and it gets weak, and it gets dead weak. Okay, double weak. And so I can't even really draw the lens that they're proposing existing, because I don't have enough center to even deal with it. I can't even make the slope severe enough and the line correct enough to sit there and tell you what this lens looks like. But I mean, it's something like, it's really a stupid looking lens. And so that is supposed to take a galaxy out here and create an image in your eye down here that's somehow coherent. And there are coherent images. The ones they are proposing to you kind of still have structure. Well, there's no way it could still have structure, because it's bending in exactly the opposite way. That is, the stuff that needs to be bent a lot is being bent none, and the stuff that doesn't need to be bent is being bent the most. I mean, how can that create an image? It's impossible. All right. So I don't want to drag on these subjects, but the flaws can be seen and they can be understood. So to understand, the bent geodesic is just the r squared rule. It's just Newton's r squared, okay, for something spherical again. It's just r squared. That's all it is. That's all general relativity is. It's r squared put into a pancake kind of two-dimensional drawing. Because if you do it in 3 dimensions, guess what? It's exactly what I've been drawing. That is, it's a force, okay, doing this, pulling, or coming from the outside as push, right? I would say it's push. Well, you can't spell push with an R, probably. All right, it's push, all right? But it's coming in from all directions, okay, equally, in, out, all directions, and that's how they teach it. When they teach the math, guess what they get? They resort to this, and this is essentially mock gravity, okay? This is mock gravity, essentially, something they mock. I mean, they're using the word mock in the sense that it's a replacement, a pseudo-gravity. So in a sense, they're mocking mock gravity, but they use it because in 3 dimensions, in 3D, the real world, 3D, this is what that stupid bent geodesic looks like. It looks like a convergence. It looks like I'm in the universe and there's arrows flying in all directions, and every one of the ones that hits me looks like it was heading right for me all the time. It's like I'm a target and the whole universe is pushing on me in equal directions. So even though all these arrows are going in all kinds of stupid ass directions, they're going all over the place, from my perspective, the only ones that get to me were heading right for me all along. I mean, it just looks like the whole universe is out to get me. That's how it's going to look from anything existing in the universe. It's just like this convergence, this in 3D. So when they do this talking that you somehow need this garbage, that garbage bent fabric crap is this. And they're just basically lying about the truth because they're giving you a silly 2D model that relies on gravity to work. It does this well thing doesn't even work, unless you use gravity to push the stuff down. No, the reality is this: it's a convergence, and it's at the r² rule, which Newton discovered as the consequence. And that rule, let's understand, that rule can be deduced by just thinking about simple things like light bulbs. I mean, or anything that's, kind of circular and radiates. The r² rule just means that it's going from a small space to a big space. And the only way it can do that is by spreading the soldiers it has. It only has, let's say, 50 soldiers. Well, if I send 50 soldiers from here, from my basement, and I send them to an area that is many times bigger than this area, there's going to be less density of soldiers. And the less density, if you send them in all directions, of the 3 dimensions, up, down included, it'll be r². That'll be the outcome, because they're spreading not only this way, but they're spreading in and out. So they're spreading in the 2 dimensions opposite their motion, and that's the square, okay, of the r² rule, okay, is that you're moving away in both dimensions. You're creating not just twice as much acreage, you're squaring the acreage that you now have to have your soldiers on. So where your soldiers were a foot apart where they started, they're going to be 10 feet apart when they get to the destination. And that's a simple principle, and it's the same principle as this visual principle. I move half the distance. Okay, my hand's here. I move half the distance. My hand is 4 times bigger. That's the consequence of this. And the same is true as a light bulb. I move the light bulb half the distance. The light bulb is 4 times brighter. You're getting hit by 4 times as many photons. The rule is a function of 3-dimensional radiation. It's just a function. It's not it's not like a rule. It's like the most basic rule, that you just can't spread the butter over the whole loaf of bread. You got enough butter for a slice of bread. You can't spread it over the whole bread without making it really, really thin. It's just logical. You can't escape it. It's such a rule. And here they pretend it's some sort of contrivance or invention, or it's just some sort of convenience, and it's not all that important. No, it's fundamental to the laws of radiating objects that are circular, that have a symmetry. Oh, shit. I was just thinking about it. It's so irritating. All right, so those are the reasons for you to understand that this whole relativity thing is useless mush. It's first full of gimmicks. I mean, Newton could have suggested bending a fabric and he would have been laughed at, because the first thing all his contemporaries would have said is, that's a 2-dimensional pile of crap. That has nothing to do with their 3-dimensional model of reality. Because it doesn't. It's for kids. It's something to fool people with. It's not something that has anything to do with reality. This stupid idea that there's gravitational lensing when the lens is the wrong shape, the exact opposite. More bending in the middle, less bending on the outside. The exact opposite of what we know as a magnifying lens. I mean, these things shouldn't have fooled anybody. And it's, I don't want to embarrass you, but physicists should be embarrassed that they fell for this. All right, so QM. So quantum mechanics, again, the very idea that so gravity also had this energy problem, in the sense that they have planets moving, being pushed, pulled, whatever, into orbits and all this kind of stuff. This is real movement, real energy. Everything else in the universe needs a rocket engine, okay, big flames coming out to move stuff. Nothing moves in your environment without some cause, an earthquake, something has to move it. There's no free lunch. And this stupid theory is a free lunch. You're just saying that somehow, by some magic mechanism, all of this stuff pulls on this thing somehow. By some magic, every little atom inside of it is saying, oh, I must go to the sun. But nothing has to tell it to in any direct way. It just knows to do it somehow. It knows to follow the inverse law geodesic, the silly well theory. It knows to follow the two-dimensional model, even though it lives in a three-dimensional universe. I'm just saying, there's just no reason. There's no explanation for where did the energy come from. Where did the momentum come from? The electron didn't just say, I have to go this way. Something had to interact with it. Something had to interact. Something had to do that. You can't just pretend it's because it feels the sun and says, oh, I have to go there. I need a vacation. It's pathetic. QM has the same problem. They have no theory of energy. So they can't explain where this virtual photon comes from. So they're basically saying that there's a charge here. So they get the charge thing, which to their credit, they figured something out. That there's, well, they haven't really figured it out because they've turned them into wacky things that don't even know where they are. But, there's this idea that there's at least electrons and protons inside of atoms. And I would argue that the neutron is just an electron and proton very close together. And so from most perspectives in the universe, it's going to look like nothing, no charge. It has an equal amount of negative and positive, and therefore it's neutralized to a nothing from a distance. And that's what happens to a magnet. A magnet from a distance is nothing. It wipes out both the north and the south poles mixed with each other over a distance, and you see nothing. You see no change in the environment. So the idea is that there's this positive and negative thing, and I'll put another negative one in just for fun. And they know the relationship that exists, and they know it's inverse. That is, the electrons hate each other, the protons hate each other, so there's some sort of energy between them, okay, that repels. And that they know that when electrons and protons are together, though, this is very weak, okay, and this is very weak, and there's no obstacle to them being attracted. So they're basically calling it attraction. They're pulled towards each other. I would argue it's just an absence of these reflections, and these reflections are the only thing that keeps things from crashing into each other because of that pressure. So again, I'll throw in a little bit of my stuff, but if you just understand that if there's two objects in the universe, and this one absorbs energy going this way, and moves a little bit really slowly, and this one's doing the same thing over here. It's absorbing this energy going this way, okay, it's gaining a little bit of momentum that way, moves very slowly. But if the two things hit, you can understand that all this energy that was absorbed will be released in a sparkling display of cataclysm. So anyway, so what's so this is their virtual photon. They know there's something being transmitted between these objects, but they can't identify it because there's no source for it. Because protons don't get weaker, electrons don't get weaker. So where do they come from? They can't say they come from the electron is just spewing them for eternity. It just has this endless source of little bits of momentum. It's just spewing these bits of momentum all day long. Because that doesn't work. They can't. They're not incredible enough, okay, to go to say these are real photons, but they really can't account for where they come from. So they have to call them virtual. So they say this is some sort of, it's just like they were little balls of momentum transferred between things, but we can't identify them. Now the other thing they don't have the imagination to do is to understand that there's, as stated, 2 + 2 + 2 physics. There's two forces. There's red force and there's black force. And the real key to making the whole thing work is to understand that when the red force hits a proton, it reflects, okay? It reflects and causes momentum in this direction. The swimmer jumps in the boat, and the opposite swimmer leaves, which is just exactly what happens. It exchanges an internal piece of momentum. So it has inside of it momentum, little bits of this force. It exchanges a force bit going this way, sits in the boat. This one leaves going the opposite way, and that means the proton has more momentum in this direction. Now, if a black bit hits, the black bit just goes, it deflects, and just leaves in a perpendicular dimension, direction. So, and the same thing happens with the electron. When the red hits it, it just gets deflected, and there's no exchange of momentum. And so that's what the C of this pressure is made of. So these little arrows are two kinds of arrows, and then there's two kinds of matter bit, proton and electron, and they act inversely. And that'll explain why magnets attract and repel. And it'll also explain why gravity isn't polarized, because these little bits in an object all add up to the same thing. There's just as many red ones deflecting as there is black ones deflecting. There's just as many black ones repelling as there is red ones repelling. So the forces are all balanced out, and so all you're really doing is absorbing momentum to create gravity. But I've sort of been over that one. So anyway, and then the other part is this wave stuff. Now the wave stuff comes from the fact that there's a few experiments where light does something when it interacts with a surface. So I have a surface, and I run a little photon past it, and the fact is a single surface will do this. The light will go next to the surface. Okay, so let me make a surface more visually real. Okay, and I have this little photon is flying next to that surface. That this photon will change its direction. It'll go some other direction than it was going by interacting with that surface. Now, that's a physics fact. It happens. And so they have some experiments where they make single slits, and then they make double slits, and then they are surprised, okay, that when they do that, this happens, that the light comes out deflected in some direction, and there's specific directions. Now, the truth is, in some cases, it fits what would happen with water waves when you put water waves through because of a concept called constructive and destructive interference. That is, if I have two water waves and they interfere with each other, they can create a phase difference. So the two of them are overlapping in specific ways. Yeah, well, I mean, whether or not I'm going to draw it precisely or not is an open question. And so there's points where the two waves meet, and they would create what's called constructive interference. That is, they would multiply 2x. You just take two humps and you just pile them on top of each other. And then there's places where the one wave is up, the other wave is down, and they would be zero. Now, the truth is you can figure there's not less pressure landing on the surface. There's the same amount of water. It's just that all you've done is taken the humps that were in one place, put them on top of each other, and so you have twice as much activity. So in water, it's up and down. There's places where the water goes up and down twice as aggressively, and then places that are calm. And so you have that at specific standard locations, all the same angle, just multiplied. So this distance is always consistent. And so it looks something like that in light. Light does something similar in the sense that there's a standardization, right, which is pretty much just an on-off pattern of where the light lands and where the light doesn't. So it just does this simple dotted line, which is, again, the simplest pattern you can make in the universe. So lots of things are going to create on-off. And that's all this really is. And it's, if we have they do a single slit experiment, and somehow they come up with some explanation that, this thing's coming in essentially as a ray photons go from point A to point B, straight line, very discrete, very small. No evidence that they spread all over the place or do anything wavy, like where they make a big wave before they come in, or do any of that. There's every indication that photons travel little discrete paths and they land in little discrete locations, and there's every reason to believe that the photon either goes close to the slit when it goes through. If I'm firing photons rather randomly, I'm going to end up going close to the surface sometime, close to that surface sometime, right down the middle sometimes. And there's going to be a certain probability. And the probability, I'd say, would be weighted for the middle. Okay, so this will be brighter. Well, of course, this does turn out to be brighter. And the more extreme deflections would be less regular. And you could just argue that all that's happening is the surface has electrons on it. All surfaces have to, because atoms are, little proton in the middle, electrons on the outside. So the surfaces always have to have electrons on them to start with anyway, in a balanced field. And we know that if I put two surfaces close to each other, okay, that these electrons hate each other, and that one side is going to say, I win. So one side's going to go positive, negative in this case, and the electrons will stay out. And the other side's going to become passive and say, okay, I retreat. Okay, and these electrons will retreat, and this side will become, the protons will become closer to the surface. And so we have these two fundamentally different surfaces now. And the photon now that goes through one surface close to the proton surface might do something different than the one that goes to the electron surface, but it doesn't really matter. The end result is you can just figure that if they're going to bend, they're going to bend based on interactions. And so you could just say that the bending twice as much means you hit 2 electrons on your way. And you go this way, then that's 3 electrons you hit. Okay, you stay here, that's only 1 electron. And the truth is you could bend this way or you could bend that way. So some pieces of light could hit 15 electrons and still end up going straight. Well, 15 doesn't divide by 2. But anyway, I don't want to get into this much complexity. I'm just saying there's explanations that don't need any of this wave crap that seems completely artificial, for which there's no evidence that photons are doing any spreading. There's every evidence that they're something moving in a very straight, narrow amount of space. And then they give you this diagram of a photon, which I've been over 4,000 times, because Maxwell saw a correlation between the force of magnetism and electricity and their speed of propagation in ideal circumstances, that they're the same speed, that magnetism moves the same speed as light. And so instead of saying, magnetism is a form of light, he did the opposite and said light is a form of magnetism. So then we got this stupid model of the photon, that they don't give you any information regarding how this makes any sense, in the sense that there's no description. Let's understand. See, this is supposed to be an electric and a magnetic field, and they draw it this way, where the two are equal. Well, this is divided by c squared here. Okay, this is that much weaker. So this lump is so thin you can't even compare it to this lump. Yet they draw it this way, which is a deception. The strength and the forces are that dramatic. So they're not even symmetrical forces. That they're saying this thing is made out of 2 of these, moving in both of these fields, and yet they're not even moving with any kind of symmetry through those fields. And then you get no description about how long this thing is. How long is this thing they call a photon? P-O-N. No description. They say the polarization has to do with this electrical lumpiness, that somehow this is defining its polarization, how much movement there is this way, which isn't a bad guess, but it doesn't really explain anything, because you haven't explained how it's moving that field in the first place, and then how putting a piece of metal in the way or some other thing that somehow that's allowing one field to pass but blocking the other? Like, how can you, they even say things like, well, it blocks the magnetic component. Well, how does it do that and you still have a photon? Still indistinguishable from a photon that hasn't had its other field blocked. I mean, that part doesn't make any sense. So, you know, you can really go into a lot of details. But let's understand there's just a superficial similarity, okay, in terms of water waves and what happens when you put light through slits. So let's understand that there's lots of ways to do the experiment. You can put a single impediment. You can put, you know, in the way of the slit. That is, this is all open space here. I don't know how to draw that, but this is all open. Okay, and then you can have a single slit. And the irony is the math for these two. So this is the open space here. This is the slit material. I guess I can do it this way. So you understand. I'll just make the material with bars on it. So these two things, they use the same math for them. And why? Because what they're putting in the equation is this distance. The distance between the slits is what's in the math. See, we think, okay, when they use the word distance here, you're saying the distance of the opening. It really isn't the distance of the opening, because you can do the same math on an obstruction, and as long as this distance, that is the width, the separation between the slits is the same. So that's the variable. That's what matters, is how close the two surfaces are. And again, just by physics, you can understand that surfaces do the same thing this way. You know, they'll tend to go positive and negative, as they do this way. They'll tend to go positive and negative. That's what they do. That's what charge does, because of the fact that these are repulsive elements and they want to get as far away from each other as possible. They want to maximize the space to overall have electrons as far from each other as possible and protons as far from each other as possible. Protons and nuclei, anyway. The nuclei as far as possible. The reason why the nuclei is stable is because of the fact that the neutron is a proton with an electron. So when there's another electron, the real magic happens, in the sense that all the red force leaves through the electron, and all the black force, okay, ends up leaving through the protons. And so you end up with very low pressure between these objects. Minimum amount. You know, just the minimum would be from random stuff that just comes in this way and bends in and then bounces off once. So there's a tiny bit of pressure that's maintained, but the fact is you get these protons extremely close to each other by creating very low pressure between them and this electron. So they call this the strong force, you know, the force holding protons together, because they think that two things are being pushed into each other with a tremendous amount of pressure. Somehow you need a tremendous amount of energy to push two protons that close together, because they know they're very repulsive and they don't want to be that close together. But they're missing this. And so this makes the electron in the middle is what makes this the strong force essentially the weakest force in physics. It's not one that you have to find the energy, because there is none. It doesn't exist. Low pressures are the explosive things, in the sense that you have a high pressure system, and any place that there's low pressure means that you have the potential to create a bunch of high pressure by merely removing this. If I remove this electron, if I kick him out of there, then I have two protons that are right next to each other, creating intense amounts of, now all the red's reflecting, every bit of it. Tremendous amount of pressure, in the sense that there's a tremendous amount of interactions. Interactions define energy. And so I'm increasing the number of interactions, and all the interactions happen at the speed of light with particles that have the same mass or momentum. And so it's the same number of it's the same amount of banging, the same bang. It just seems like there's more bullets, because they happen to hit something more often. And you can understand that if that was happening to you. If you're standing facing another person and you both had bullet reflectors, you can understand somebody could fire the bullet, and the further away you get, the less the bullet hits you. The closer you get, the more the bullet hits you. It's that simple. So this has high potential for being explosive, but when the electron's there, you can't get more stable. So anyway, it's going farther afield than I really wanted to go. So back to the slits. So it's really the distance between the slits. That's all this really is. It's the distance between the surfaces, not the slits, sorry. Surfaces are what's playing the role. Surfaces are defining the outcome. The closer the photon is to the surface, the more likely it is to be bent. That's why I make the surfaces closer and closer, you know. If I make them closer and closer and closer and closer, what's the obvious implication of doing that? The obvious implication is that if I'm just randomly shooting photons, I'm more likely to be right next to the surface, right? The closer they are together, the more likely it is my photon's going to be right next to a surface. And therefore, it's going to hit more electrons, and therefore it's going to deflect more, and that's exactly what we see. We see more deflection. The smaller the slit, the more the light spreads. Okay, the more it goes in all of these other directions, because it's going to hit more electrons, because the electrons are on the surfaces. That's simple. It really is that simple. Protons are technically never on the surface, so you're never going to hit a proton probably. You're just going to hit electrons that are closer to their proton and electrons that are further away from their proton. So they're going to have different amounts of tension that they're going to be held by. So some electrons, the electrons you hit on one side will be low tension, the ones on the other side will be high tension. So you're more likely to be deflected from one side dramatically in either direction. Both surfaces are spreading the light both ways. All right, theoretically. All right, then you have the double slit, okay, where they think it's some sort of, like Newton had already done it. Essentially, this is the double slit in a sense. You're missing these two surfaces, of course, which are very important. But when they do the math, they just pretend this distance is always the same. So they don't even have math where you can vary the distance of the outside slits. So when they do the math for this double slit, so this is the surface, this is surface, this is surface. When they do the math for this, okay, they put this as the distance. Okay, they don't have the width of the slits as the distance like they did in the single slit. This was the D variable here. But in the double slit, this is the variable. So they don't have this in the math. There's no room for it. There's no place for this variable. So they just assume this distance. So the distance between these two slits is just assumed. So if you change that distance, their math won't work. But the key thing is this pattern ends up being a lot more complicated in the sense that there's two patterns. So there's one pattern doing one thing, and then there's another pattern on top of that doing something else. So the bars come out in packets. Big packets in the middle, smaller packets as you go further out. So you have two patterns. You have the pattern of these lines, and then you have the pattern being created by these lumps. They don't account for those two patterns at all. They have no theory of why it exists, no explanation for why it exists, and yet they say, oh, it's just like water waves. So water waves just creates the bars, no double pattern, and light creates this double pattern. And so they pretend it's the same when it's not the same. All right, so let's go to, and so then when you add more slits is when it gets even more interesting. Is if I put a whole bunch of little slits, and then I shine light, I expose that whole area to light, what I end up getting is images at all these locations of whatever this was. So whatever this was, if it was a duck, all right, I get little ducks here, little duck, little duck, little duck, little duck. This whole thing ends up going, the whole image ends up going here. So that means this provides a portion, this one provides a portion, this one provides a portion, this one provides a portion, and likewise to all the other ducks. So there's a bending to these specific locations. They're getting further and further apart now, and these specific even though I made the slit smaller, the bars are getting way far apart, spreading dramatically, because they are tiny surfaces, so the dispersion gets wider and wider. So I'm making the slits smaller and smaller. But now I'm getting more and more resolution. So what I'm basically doing is sending this image here and here and here and here and here, and phase shifted, but let's not get into that. But they don't. Wave theory won't do this. So if I put a bunch of waves coming out of this thing and I cause wave interference, I'm not going to get an image here. I'm not going to get an image here. I'm not going to get an image here or an image here, because they've randomized. Their theory is it doesn't matter whether the photon goes in here, here, here. It doesn't matter where the photon goes in. It does the same thing coming out, in the sense that it creates two waves that interfere with each other, and they do their math. But it's completely can't be the truth, can't be how it happens, because it won't produce the results they get in the experiment. So you can demonstrate that this foundational assumption that somehow light is a wave, that the experiments that gave them that indication are fundamentally flawed. Their assumptions are wrong, and there's just no reason to make a photon into this wavy thing. It's not doing anything wavy. It's moving momentum in clumps, and you need a certain number of them. We know that from our own vision. You need 6 of these clumps, or you're not going to recognize the photon. You're not going to see this frequency unless it hits you 6 times. It has to be at this frequency. And if I change one of these, and I move this like it's the same frequency, but there's one little part that's off, so I make the same frequency and then a wider space and the same frequency, and then this won't work. Okay, this won't be detected because of this break in it, because that broke the ability to send the information. And polarization is just these things, and just recognizing that they're not in perfect alignment. Okay, their frequency is perfect, but their alignment's a little bit off a straight line. And polarization is basically a polarizing filter, just kind of changes the phase of one of these, so it ends up here instead of there. It's moved in space and time because it goes through another material that causes it to effectively, the consequences, it slows down. The consequences, that's delayed. Delayed would be the more appropriate word. So one of these ends up going through part of the material that will delay it a little bit more, and by being delayed a little bit more, now it's out of phase. Now this can't be seen as a photon in this form, but it still has all the energy of the photon. That's why the polarizing filter doesn't get hot. It's because the energy went through. It's just now in a form you can't detect as a photon. But if I put it through another filter, I can push this guy back to where he was. Or I can move all of these guys consistent with that other one. But at any rate, I fix the frequency again. Alright, I repair what was broken in this photon, and now this photon is visible. Okay, and now it'll be seen. That's the simple explanation. It works, it satisfies, and there's no need to have any, whatever this is, whatever this field crap is. There's no field. The field is made out of energy. Energy is what decides where something goes. You have to hit it with a corpuscle of energy. The thing has to absorb it. Alright, so I'll do just a simple absorption argument and be done. So another key component of quantum mechanics is the fact that electrons seem very erratic. So electrons don't seem to have a position, because they seem, when you try to measure one, there always seems to be some sort of momentum issue. It always seems to be going somewhere. And the simple explanation for that is that, as I've stated, it's a boat. And energy, when energy comes into it, the idea is the boat has seats in it. It only has 5 seats, let's say. It's probably 5 million, but it doesn't matter. When an electron goes in, basically what's happening is the momentum this way takes a seat and throws out momentum this way. So there's your equal and opposite reaction. But the consequence of that is that this stored energy, and that's what this is, the electron has stored energy. The arrangement of the stored energy now is 3 to 2, where before it was 2 to 3, 3 to 2. So it started off having 3 going this way, and now it only has 2 going this way because it had to give back 1. And now it has 3 because it took a new one in. So now its proportion went from 3 to 2 to 2 to 3. So it was going this way, and now it's going this way. And it's doing that in all three dimensions all the time. So at any one moment, the electron is always moving that way, or it's moving this way or that way, or it's moving in or it's moving out. And that combination creates a momentum in the universe. That's its net momentum. And that decides where it moves. It decides, the force decides, the bits hitting it decide. The external field decides, and that's going to be decided by the electrons and the protons that are reflecting that field at each other. They're all like mirrors, opposite mirrors. The proton has an opposite mirror to the electron. Opposite stuff gets reflected, and that's the mechanism, essentially. So the reason why the electron's constantly wobbling is because of its internal design. It can't do anything other than constantly wobble. It has to either go this way or this way, because it's got this odd configuration. And the proton can sit where it can be much more comfortable in one location, because the proton has 6 seats. So it can have 3 and 3. So where the electron can only go +1, -1, the proton can go 0. But there's no 0 for the electron. Not that protons are ever stable, because they have the same thing. One little tiny bit jumps in the boat this way, it starts to go that way. And that's your law of probability. Laws of probability say over time you're going to flip just as many heads as tails, and the universe is doing the same thing. So at any one moment there might be 3 extra heads in the boat, but you go find another moment, you'll find 3 extra tails in the boat. And it's always wobbling between those positions based on how much energy is in the field. And the simple argument is the field is constantly forcing things to slow down. Drag is a real thing. The elemental bits to slow down. The electron and proton can't maintain much velocity, because as you can understand, if I have more momentum in this direction, I have a 5-to-1 bias, let's say, and I'm going this way, well, I'm moving into the force, the even force. There's just as much stuff going this way, force, as there is going this way, let's say. Well, if I'm moving into it, that means probabilistically I'm going to hit more of these, okay, which are going to jump in my boat, than these. The swimmers trying to catch up to me, even though I'm not going very fast, but they still have to catch up to me, are going to be, fewer of them are going to jump in the back of the boat than the ones hitting the front of the boat. And so therefore I'm going to go to 4-to-2, and then I'm going to go to 3-to-2, 4-to-1, and then 3-to-2, 5-to-0 here. So I'm going to be slowed down, and so electrons display exactly that behavior. Protons do too. Accelerators have to use so much energy because they can't just speed up these things and they just keep going. They can't just trap them and give them velocity and they just keep moving really, really fast, spinning around. They have to keep pumping energy in. They have to keep pushing them with energy to get them to go faster and faster. And the faster they go, the more energy they're hitting into. So it gets harder and harder and harder to gain speed. The first 30 miles an hour you go doesn't cost as much as the second 30 miles. And the third 30 miles is even more expensive. And the fourth 30 miles is even more expensive. It gets more and more expensive for electrons to be pushed the faster you're pushing them, because drag is so real for them. So the zillion milliwatt, they use these huge amounts of wattage to define electron volts. They say electron volts, 1 trillion electron volts, accelerator. Well, the reason why it has to use so much voltage is because it has to push incredibly hard to get this thing to go half the speed of light or 3/4 the speed of light. It requires a tremendous amount of energy they have to keep pumping into this thing to get that big of an imbalance to be maintained. And again, they can't maintain it. They can't get it up to 3/4 of the speed of light, and it just goes around and around and around in the circulator. It won't happen that way. They can't do it. They can't trap it, and it keeps its momentum. Its momentum is eaten up by its velocity, by the headwind, because it doesn't have a motor. Now, matter, that is, when you configure things together. So I'll do that as the last little bit, and I've done it before, but I'm just to understand. So material things, you can throw them into space and they'll go forever, no drag. That's because they're made out of matter. So the smallest thing that can do that is like a helium nucleus. And basically the idea would be is that that would have extras of these bits. I probably should draw it as protons. So I could argue that if I had two protons here and an electron, and I have them in this configuration, that is, this is a 90-degree angle here inside this electron. You could argue that by the rules, these simple rules established, the red force would deflect 90 degrees. It would hit this other proton, then it would bounce back, deflect 90 degrees, and then bounce back, and then deflect 90 degrees, and then bounce back and deflect 90 degrees, and it wouldn't escape. So it would just keep doing this. This is the perpetual reflection. So any bit that goes in here and gets in this trap, okay, will just keep bouncing back and forth, back and forth, back and forth. So there's no momentum in this direction because the electron is just deflecting. There's real momentum in this direction and in this direction. And you can understand that those two directions equal this direction. All right? So this is why nuclei can move through space without being dragged down, is because the closer these things, the closer these electrons, these protons get to this electron, the more their energy increases in terms of the pushing force. So the more you try to compress them, the more they fight back. And so you'll maintain your velocity because you have this inside of you. So when there's astronauts in the space shuttle, what's happening to their nuclei is essentially the atoms inside their nuclei are doing this. Okay, and the nucleuses are doing this with the electrons and the protons. And so they're creating inside that nucleus these little motors, okay, where the energy is going to start lining up in the direction of the momentum. So all of them are starting to line up in the direction of the momentum. That's why it takes a little time for you to accelerate, is because all these things have to turn their position. And now you can maintain your velocity because essentially you have this engine inside of you. The more I compress, the harder it fights back. I've balanced against the drag, and I'll keep going. All right. So all of this is so, every bit of physics can be explained with a simple, logical understanding that it's really just made out of stuff going the speed of light, the universe, the little force bits of momentum. All the forces move the same speed, light, magnetism, electricity in a perfect conductor. So you don't need any of this quantum mechanics stuff. You don't need this relativity crap. None of this crap is necessary to understand why things are moving. And they're moving because they're getting hit by real forces. Real forces affect matter. Forces don't affect forces. You can't shoot photons into photons. You can't shoot gravity into gravity. They only affect the electrons and the protons because they're the charged elements. They're the things that can either reflect the energy or deflect the energy. And whether you deflect it or reflect it has a huge impact on the rest of the universe. It's just a fact. It changes what you're radiating. And it changes where force is moving. And that's fundamental to their being change, is being able to change where force is going. If the force was heading right for you and I deflect it somewhere else, I'm changing the universe. I'm clearly changing it for somebody over there who gets hit by the bullet, and I'm changing it for you because you didn't get hit by it. It's that simple. So once you have a mechanism that can deflect energy or reflect energy, you're changing the universe. I would assume enough said, but that assumption will be proven futile and pointless. I have to assume you're belligerent idiots, and I will still get arguments about somehow it doesn't work when it fits perfectly. All right. Until next time and such.